simplifying trigonometric expressions. Now, in problem 6, we are tempted to turn all of these non-sine or cosines into sines and cosines. It literally will work. But what you should probably try to suss out here is you'll notice that cosecant and sines are reciprocal functions. Also, cotangent and tangent are reciprocal functions. So, what we may want to look at here, and this is another kind of cool way to think of the problem, is let's rewrite it like this. Cosecant theta multiplied by 1 over sine of theta. You see how this cosecant theta divided by sine theta can be rewritten like this. Because if I went top times top, bottom times bottom, I'd get back to that problem. Let's do the second piece now. So cotangent theta multiplied by 1 over tangent theta. Okay, again, you can see that if I went top times top, bottom times bottom, that would give me what I want, or, back to this expression. So you're probably still thinking like, well, Anderson, what am I doing here? Should I turn these into sine and cosine and turn that into sine and cosine and that? No, don't, because 1 over sine is the same thing as cosecant theta. Okay, so now I have here cosecant theta times cosecant theta, which is going to make cosecant squared theta, because it's this is cosecant theta squared, and we can move the square to the inside. Okay, so let's now focus on the other side, right? So we had our cotangent theta times 1 over tangent theta, but 1 over tangent theta, that is cotangent theta. Yeah, this is a reciprocal identity. And that means that cotangent theta times cotangent theta is going to be equal to cotangent squared theta, because cotangent theta times cotangent theta is cotangent theta squared, which is the same as cotangent squared theta. And you're wondering, why is this important? Well, cosecant squared theta minus cotangent squared theta, if you see the squares, you may want to check your Pythagorean stuff here. So let's go back to our first page here. Let's go back here. Oh, check it out, Pythagorean identities. And do we have cosecant squared theta minus cotangent squared theta equals 1? And ladies and gentlemen, cosecant squared theta minus cotangent squared theta, the answer to this problem is 1. It is 1. And you have to show your work there if you were doing this as a paper pencil assignment, but you could have done this a much more elaborate way if you converted everything to sine and cosine. If you want to try that as an academic exercise, be my guest, but this is the efficient route. Now let's check out sine theta plus tangent theta over 1 plus secant theta. Now this is a problem where I'm going to introduce a not so great topic from college algebra, complex fractions. You can see that I'm going to take this sine theta plus tangent theta, and I'm going to turn everything that's not a sine or a cosine into a sine or cosine. So my numerator is sine theta plus, now tangent is written as sine theta over cosine theta. My denominator is written as 1 plus, I'm going to write that as 1 over cosine theta using the reciprocal identity. And now everything's written in terms of sine and cosine. Now, this is something called a complex fraction. And it's called a complex fraction because you have a fraction divided by another fraction, or in this case, binomials of such. Now, I haven't taught college algebra in a long time, but I did so for many, many, many years. And my strategy for dealing with these is to get them into basically a combined fraction in the numerator and a combined fraction in the denominator. You will see that this technique actually works pretty nicely. So if I am to convert this numerator here, which I will highlight in yellow, if I'm trying to convert that into one fraction instead of a term plus another fraction, I'm going to need to change this sine over theta to have a common denominator with this cosine theta. So I'm going to multiply by 1. and this 1 is going to be cosine theta divided by cosine theta. Multiplying by 1 is a legal operation. So now what I have over here is I have cosine theta sine theta, all divided by cosine theta, plus sine theta divided by cosine theta. So this is my numerator that can now be put into this expression, all over cosine theta. Okay, so now I have cosine theta sine theta plus sine theta. Okay, so now my numerator of this complex fraction got converted to the red and got converted back to blue. And we can work with this once we do the same thing to the denominator here, which I'm going to highlight in green. Okay, so this denominator is now going to get basically simplified because this 1 can't be put together with the 1 over cosine theta until we have a common denominator, and I'm going to multiply the 1 by 1, or cosine theta over cosine theta. This gives me cosine theta over cosine theta plus 1 over cosine theta. And then I can combine that over here to cosine theta plus 1, all divided by cosine theta. Okay, so looks like everything is going pretty straightforward here. So now what I'm going to do is I'm going to take this fraction on top of a fraction, and I'm going to highlight again the numerator in yellow, and I'm going to highlight the denominator in green. And to show you what happens next is I sing my little lullaby here. Dividing fractions, please don't cry. Skip, flip, and multiply. So we're going to skip what's in yellow and write that normally. Cosine theta sine theta plus sine theta divided by cosine theta. And I'm going to show this to you in yellow just so you don't lose track of it. And then we're going to multiply by that denominator, but we're going to flip it on its head. So the denominator flipped on its head would be the cosine theta over the cosine theta plus 1. So again, this is in green, so you don't lose track of where we are here. I put my 1 there. Bam. Okay. So, through the power of cross simplification, the cosines simplify. In complex fractions, back in college algebra, this step here was pretty common, where you had the two denominators of this complex fraction simplify or cancel out. And that means that in this numerator now, we have basically this whole thing times 1, so cosine theta sine theta plus sine theta, and my denominator is now cosine theta plus 1. And you might be feeling like, woo, we have done a lot of simplification, but it surely doesn't look any easier than problem number 7. That's because you're missing one more step. Can you see something about the numerator that might help us here? You'll see that the first term is cosine theta plus, or cosine theta sine theta plus, and the second term is just sine theta. Well, factor out a sine theta in the numerator. So this makes sine theta in the numerator multiplied by a factor of cosine theta plus 1, and then my denominator is now cosine theta plus 1. And I showed you in the canceling no-nos that this was actually completely and totally legit. So your answer to problem 7 is sine of theta, which is a lot easier than that. This whole thing is sine theta. Amazing, right? Well, you did it, guys. You just simplified this trigonometric expression here. How cool is that? All right, now, that was a big one, right? Wow, you didn't see where that was going, but we have 2 more to go. And this next example here does another complex fraction as well. Whoops, I'm not going to go that far today, or in this video here. So let's do problem number 8. Problem number 8, and this is going to be one where we're going to want to turn this into sine and cosine. So let's take my numerator here, the cotangent, this yellow numerator right there. I'm going to turn this into cotangent, which is going to be cosine theta over sine of theta. plus the tangent is going to be sine of theta over cosine of theta. Now my denominator. Now you're probably going like, well, how do I turn that into sine or cosine? Well, the cosecant is the same as 1 over sine, so this is going to be 1 over sine squared theta. All right, now that's going to be important. You're going to want to see why that is important right there. So let's check this out and see what it gets me. All right, because now I'm going to check out my numerator here. My numerator here is going to be... It's going to be needed to be combined. See, my numerator here, I've got this cosine over sine, I got this sine over cosine. What I really want is I want to turn this into one common denominator. And my common denominator is going to be sine theta cosine theta. So I got to multiply this first fraction by 1, or whoops, not sine, since it has a sine already. I'm going to want to turn this into cosine theta, because this is like, this denominator doesn't have a cosine, so I'm going to have to give it one. So my numerator is now cosine times cosine, which is cosine squared theta. Now this fraction here doesn't have a sine, so I need to multiply this by 1, or sine theta. So cosine times sine gives me my common denominator, which I can just, reverse the order. But now my numerator is sine squared theta. And my denominator is still waiting here, still waiting to get finished. And I didn't highlight it anything because just not much is getting done with it. So this is sine squared theta. Now, what do you notice about this numerator, cosine squared theta plus sine squared theta? Well, go back to your front page of this unit worksheet. Cosine squared theta plus sine squared theta is in fact 1. So now I have 1 divided by sine. I should probably have done that in blue just so you'd see where it came from. Okay. Okay, so I got 1 over sine theta cosine theta. Okay. And then this is divided by 1 over sine squared theta. All right, now we keep moving on, and we now do our skip, flip, multiply. So I will now highlight this in yellow. This is still our yellow numerator. And this white, I can now kind of highlight this as our green right here. This is our green, and that's going to be here. So we're going to take our 1 over sine theta cosine theta. That's our numerator in yellow. Okay, just so you don't lose track of it. Come on. Oh no! This is where the Microsoft is saying too much on the screen, too much on the screen. Let's see if I can get it to, okay, there we go. And then we're going to move on to our, slowing down here. Now we're going to move on to our multiplying problem here. This is going to be our 1 over sine squared theta is now going to be sine squared theta over 1. See, we just flipped this green part on its head like that. Can we do some cross simplification? Sure can. We can take out one of those and take out one of those. So now we have sine theta over cosine theta, and sine theta over cosine theta is tangent. Yup, this whole answer is tangent. So cotangent theta plus tangent theta over cosecant squared theta is tangent theta. All right, should probably have a little arrowhead on top of that. There you go. Woo! Wow, this is crazy, right? Here we are moving to our final problem. And this is a tough one. This is a tough one. And the tough one is because this is going to get us to another concept called FOIL. Oh, man, foiling. And what we have here is our first strategy is foiled. It's ruined, and I mean FOIL is in terms of ruined because you can see that everything is already in sine and cosine. If everything is already in sine or cosine, what that means is we have to maybe look for another strategy. So if you are stuck, because everything's in terms of sine or cosine, get a common denominator. All right, so how do we get a common denominator? Well, it looks like this side is 1 plus sine theta. So I'm going to multiply this side by 1 minus sine of theta, okay? 1 minus sine of theta. Okay, and this other side right here, this 1 minus sine of theta is now 1 plus cosine of theta. 1 plus cosine of theta. All right, so we're going to now multiply these numerators by 1 plus or 1 minus sine of theta. So this numerator is now, if we distribute the cosine to it like so, this makes cosine theta minus cosine theta sine of theta. All right, and what we're going to do is distribute this cosine here and here. So what I have here is now plus cosine theta plus, now cosine theta times another, oh shoot, I messed this problem up. I messed it up real bad. Because this shouldn't be 1 plus cosine theta over 1 plus cosine theta. Silly me. It should be 1 plus sine theta over 1 plus sine theta. All right, now this is going to make a little more sense here. Sorry about that. 1 plus sine theta plus 1 plus sine theta. All right, so cosine times 1 there is going to be just cosine theta. And cosine times sine theta is going to be plus cosine theta sine theta. And this is going to be all over the common denominator now, because this common denominator is now 1 plus sine of theta and multiplied by 1 minus sine of theta. Now what's going to happen here is going to be an amazing, awesome cancellation jamboree. All right, this is going to be so fun, because what's going to happen is this, you see this negative cosine sine theta? That is going to simplify with this. And you can say cancel, because that actually makes a 0. And then I have this cosine theta plus cosine theta. Now, don't fall into this trap, because sometimes when people say, oh, cosine theta plus cosine theta, that's cosine squared theta. And no, it's actually 2 cosine theta, because this is like one of these plus one of these gives me 2 of them. But what about my denominator now? Now you see I don't actually have a very long written denominator, because what I'm going to do is I'm going to foil these binomials, because what you're going to see is if you have a binomial that's similar but slightly different than the other binomial with the subtraction, you're going to see this as a difference of squares. So 1 times 1 makes 1. That's again the first cable, the f of the FOIL. And then this times this is the outside term, so this is negative sine of theta. And then we do the inside terms here. Okay, the inside terms is going to be positive sine of theta. And then we do the last terms here, and the last terms is going to be negative sine squared theta. So these simplify to 0. And this is what I have. I have the minus sine squared theta. All right, now, what is 1 minus sine squared theta? Look back at your first page. What is 1 minus sine squared theta? 1 minus sine squared theta is cosine squared theta. They're equivalent. All right, and I probably should not have had a plus there. That should have been a arrow instead of a plus. I apologize for that. All right, and so now I have 2 cosine theta divided by a cosine squared theta. Well, just take out one of those with one of those, and now we have an answer of 2 divided by cosine theta. That is your answer. Can you believe that? All of that simplified down to 2 divided by cosine theta. Wow, great work today. Now, I am totally honest with you that these are some pretty tricky techniques to have just tried to figure out on your own. So you watched a pro do it. I strongly recommend that when you try these expressions on your own, the first thing you should do is try to maybe look for reciprocal functions that are above each other, like in problem number 6. I think you should then try to convert everything into sine and cosine. And then you should try to get common denominators. And then you should try to simplify or cross cancel. I mean, you're only going to get good at this by practicing, and you're going to lose a couple times when you start doing these, so you may want to like sign up for a little help session with me through Zoom or through office hours. So please reach out to me if you're my student in class. Give these a try. I appreciate you sticking with it. The next 2 videos, I promise, are a lot shorter because they're going to deal with just converting things into sine or cosine, or combine them into one kind of term, either in sine or cosine. So thank you very much for watching. I appreciate your hard work and effort.